MetaHarmony is a music analysis system created by Tom Glazebrook in 2020 that aims to give a new perspective in music theory using colors and geometry. His theories used to be presented in the MetaHarmony YouTube channel and in the MetaHarmony official video course, where he gained a small but dedicated fanbase. However, as of June 2023, both of these have been deleted. As a way to preserve a lot of his ideas and to pay tribute to the MetaHarmony community, this video aims to explain most ideas behind MetaHarmony in a comprehensible and very beginner-friendly way. I'll try to present a version of MetaHarmony that is as close as possible to the original, however with some new shorts and insights by me. With all that said, let's begin. MetaHarmony's first point is that all three foolishly meaning 7 chords form the basis of all chord movement. These are called primary colors: red, blue, and yellow. Now, with these primary colors, we can combine different notes from each in order to create our common major and minor triads. Here's C major, here's C minor. These will be our secondary colors: orange, created by mixing red and yellow; purple, created by mixing red and blue; and green, by mixing yellow and blue. This model is called the color wheel. By putting the secondary colors onto the circle fifths, we soon discover that there are 3 axes of minor third related keys: a green one, an orange one, and a purple one. The biggest music theory aficionados among you will see the similarities between this and Ireland's Bartók axis. Since these keys are equivalent, the chords from one key might be used as substitutional possibilities in another. Thus, we arrive in the following chart. The tonic chords are in the middle, subdominant ones are at the bottom, and dominant ones are at the top. A fun fact you can see is that the 3 chord, instead of the common tonic, is considered dominant because it is the 5 chord of a relative minor and shares 2 notes with the major 5 chord. To the right, there are the so-called couple chord, or as I prefer to call them, approach chords, which are 4 pairs of secondary dominant and secondary minor 6 chords that get attention due to the tritone inside them, therefore being able to resolve directly to the chords on the left. However, we can rearrange this graph so each function goes from left to right. In this way, each color will get its own column, and while this chart could go on forever, I'll keep it relatively small for readability's sake. I'll make one more alteration. I'll move each element of the dominant column upwards. Why? Because in this way it becomes relatively simple to see all possible movements between chords in a pretty consistent manner, such as the couple chords. The dominant 7 of the major chords resolve to the right, while the minor 6 of the minor chords resolve to the left. Other advantages of this chart is that it allows me to see a number of different movements: the perfect cadence, the backdoor flat 7 cadence, the tritone substituting cadence, the standard avoid cadence, the Kyrie eleison cadence used by Mozart in his D minor Requiem. And even this rather bizarre median cadence. We are not limited to cadences either. We can also find the secondary Neapolitan chords of the dominant chords only a tritone away, the classical augmented 6 resolution, the hexatonic progression, whole tone progressions, and octatonic progressions within each column. One could easily identify functions of each of the church modes. This is leading, Ionian, Mixolydian, Dorian, Aeolian, and Phrygian. Needless to say, these will prove very useful for non-functional harmony and modulation. Alright, but how about diminished chords? Well, let's go back to the color wheel. Diminished and half-diminished chords can resolve to the secondary color in three different ways. The so-called complementary resolution, which is the strongest, the syntonic resolution, and the gamma resolution, the weakest of all three. In our chart of pillars, the complementary resolution should be represented by going from any diminished chord to the left column, the syntonic resolution by going to the right, and the common one, where the diminished chord resolves to any chord in the same column. As for the augmented chords, we don't need to learn anything new about them, as they retain their same function as the major and minor triads. Now, for some analysis. Note, minor harmony doesn't claim any of the composer's thought of harmony this way, only that we, nowadays, can look into the compositions in order to extract ideas and move them for our own practices and compositions. The next big thing in minor harmony is its geometrical models. Taking direct inspiration from Dimitri Klimatsov's A Geometry of Music, Tom crafted a number of geometrical models so one could, if they wish, have a physical representation of harmony in real life. Let's go back to this chart. Do you remember it? The tonic function triads are at the middle, subdominant ones are at the bottom, and dominant function triads are at the top. By making small cubes of each, you create what are called alpha cubes. And by stacking these alpha cubes and stretching the upper and lower faces in order to create another bigger cube, you create what is called a hypercube. We can create three hypercubes: an orange one where the orange alpha cube is in the middle, a purple one, and a green one. In these hypercubes, you can add small corner pieces in order to represent the coupled chords. However, since adding all of them would make the picture too convoluted, here is only the diatonic corner pieces of the green hypercube in all four keys. There are also other geometrical models in minor harmony, such as the arcade, the hexaprisms, the atrium, and the metaprism. However, I'll leave these to another video as they deserve a video of their own. By the way, if you want to see more about the hypercube and to see all corner pieces, user Nuno Cortez of the Minor Harmony Discord server made a web app so you can see more of it and of the color wheel. The link is in the description. Over the history of Western music, how consonances and dissonances should be treated has changed drastically. The seventh, once a dissonance that had to be properly treated and resolved in the common practice period, has become the core foundation of jazz harmonic thinking with no need to prepare and resolve it. In most jazz and modern harmony books, there are the so-called extensions, which are richness tones one can add to the basic triad in order to make it harmonic richer, like the 6th, the 7th, the 9th, the 11th, and the 13th. However, what if we were to resolve them? This is where the color wheel appears again. First off, let's take our C major chord. There are two types of extensions. Extensions that are stables in and out of themselves, which are, for the major triads, the add 6, and for the minor triads, the minor 7th. And those who can resolve, which are all the rest, and can be divided into three groups. Those that come from the complementary primary colors, the ninth, the 11th, the flat 6th, and the nominal 7th. Those who come from the cytonic primary color, the flat 7th, the flat 9th, and those from the same primary color as the root, the sharp 11th, and the sharp 9th. We may repeat this process for the minor triads, and we end up with the following list. The cool part about these extensions is that, just like the diminished chords, they may also resolve in three different ways. Let's take each one of these and see how they resolve. Complementary extensions resolve complementary to the chords of the same column, synctonically to the chords of the left column, and commonly to the chords of the right column. Synctonic extensions may resolve complementary to the chords of the left column, synctonically to the chords of the right column, and commonly to the chords of the same column. As common extensions, they may resolve complementary to the chords of the right column, synctonically to the chords of the same column, and commonly to the chords of the left column. Something cool you can do about these is that you can analyze how the extensions and the root are resolving, then hide some of the chord tones, creating chordioid resolutions. Normally, when we are dealing with border chords, notes not found in the original scale will appear. This is what happened, for instance, with the major 5 chord in minor during the column practice period, when, by seeking a stronger resolution towards the tonic, composers altered the 5 chord in minor to major, creating the harmonic minor scale. However, problem may appear when dealing with this melodically. When you go from the 6th scale degree to the sharp 7th, you end up with an augmented second, which is a quite awkward and hard interval to sing. So composers alter this scale degree a half step up, thus creating the melodic minor scale. But what happens if you use a different chord? How do you alter the scale to make it fit? This is when the paratonic scales appear. Paratonic scales are momentary scales you apply above a non-diatonic chord by altering the original horizontal scale. Let's see how they are constructed. The first step is to write down the original scale you want to alter. Let's take C major. Now, write down the chord you want to use the scale above. I'll take F sharp dominant 7th and write it down starting from C sharp. Now I'll alter the original scale so each of the chord tones fit. You could, if you really wanted, to use this scale above the F sharp dominant 7th. However, there is this annoying augmented second between the G and the A sharp. So what we would do, let's raise the G to G sharp. Perfect. Now that the augmented second is gone, this scale is much better for melodic use. Nice, you may say, but do I really need to do all these calculations every single time I want to use a chromatic chord? The answer is not so much. User El Shabini in the Meta Harmony Discord server has made an online calculator to spare us all this trouble. The link is in the description. After all of these, you might be asking, why bother? Do I really need to use colors and geometrical models in order to create great harmony? The answer is no. Meta Harmonies is one of the multiple systems out there people use in order to create harmony. Some people, in fact, don't even have one. They just follow their inner ears and gut feeling and are very happy doing so. Heck, you could, if you really want to, create your own musical system by extracting the best part of Meta Harmony. I myself am not a big fan of seeing chords as purple, orange, and green, and not so much of the geometrical models, so I use a lot of the Meta Harmonies concepts such as the axis substitutions, the extensions, and the paratonic scales without thinking about color and geometry. That's it. I encourage you to give the Meta Harmony way of thinking a try. You never know if you like something or not if you never tried, so why not give it a go?